This video lecture is recording conversion of NFA to DFA under the course Formal Language and Automata Theory. This is BNV National Raju, Assistant Professor, Department of CSC, SRK Engineering College, Pimbaram. The objectives of the video lecture are to learn conversion of NFA to DFA, to apply the conversion of NFA to DFA. So first we are going to see the conversion of NFA to DFA. Let L be a set accepted by non-deterministic finite automata, then there exists a deterministic finite automata that accepts L. Proof. Let n is equal to Qn sigma delta n Q naught Fn be the NFA accepting L. That is, NFA n with 5 tuples are known and we need to define the 5 tuples of DFA D. Let us define D is equal to Qd comma sigma comma delta D comma Q naught comma Ft be the DFA D. We observe that both the NFA and DFA having same input symbols. Means the sigma is identical in both NFA and DFA. Let us define the states in the DFA. Let us define Qd is equal to 2 power 2. That is the set of all subsets of Qn in NFA. That means the states in DFA will be the subsets of the states in NFA. Denote the states of the DFA in the form of square braces Q1, Q2, Q3, so on, Qi, where Q1, Q2, Q3, so on, Qi are individual states in NFA. These are all individual states in NFA, but it is a single states in DFA. Now we define Q0 is equal to Q0, where Q0 is the initial state in NFA. Means the initial state of NFA is Q0, then the initial state of DFA is also Q0. Delta D is defined in the following way. Delta D of Q1, Q2, Q3, so on, Qi, comma A, that is equal to P1, P2, so on, Pj. If and only if delta N of Q1, Q2, Q3, so on, Qi, comma A is equal to P1, P2, P3, so on, Pj. It means NFA for single input symbol A, it goes to the states P1, P2, so on, Pj, and then DFA also goes to the same state for the same input symbol. So this is shown by using some mathematical induction on the length of the string x. That is, show that delta of Q0 comma x is equal to Q1, Q2, Q3, so on, Qi, if and only if delta n of Q0 comma x is equal to Q1, Q2, Q3, so on, Qi. So basis. Let mod x is equal to 0, that is equal to x is epsilon, means empty string. In this case, the result is trivial. So that is delta D of Q0 comma epsilon is equal to Q0 if and only if delta n of Q0 comma epsilon is equal to Q0. Induction. By inductive hypothesis, let us assume that the result is true when mod x is equal to n. Now, let xa be the string of length n plus 1. Delta D of Q0 comma x is equal to delta D of delta D Q0 comma x comma a. In hypothesis, it was considered that for string x, the definition delta D will be true. From hypothesis, delta D of Q0 comma x is equal to P1, P2, so on, Pj, if and only if delta n of Q0 comma x is equal to P1, P2, so on, Pj. Now delta D of Q0 comma x comma a, that is equal to delta D of P1, P2, so on, Pi comma a. So this is nothing but hypothesis. From hypothesis, we have replaced it by P1, P2, so on, Pj. From the definition, delta D of P1, P2, so on, Pj comma a is equal to R1, R2, so on, Rk. If and only if delta n of P1, P2, so on, Pj comma a, that is equal to R1, R2, so on, Rk. In DFA, what happens means delta D of Q0 comma xa is equal to R1, R2, so on, Rk, if and only if delta n of Q0 comma xa is equal to R1, R2, so on, Rk. In DFA, the set of final state Fd contains all the states in DFA which contains one of the final states in NFA. Hence L of n is equal to L of t. For example, the NFA transition table was given. Here the Q0 is the initial state and Q2 is the final state. Now we need to construct the equivalent DFA. So we are going to construct the transition table for DFA first. So it consists of states and inputs. In both NFA and DFA, input symbols will be same. So input symbols are 0 and 1. So both will have the same initial state, that is Q0. Now apply Q0 0 in NFA. It goes to the Q0 Q1. The same will be for DFA also. But here Q0 Q1 are individual states. Here Q0 Q1 is a single state. Next apply Q0 1. So it is Q2. Here is also same. So after applying Q0 0, we got two new states, that is Q0 Q1 and Q2. So pick one of the new states and apply 0 1 for it. Repeat for all the new states in the same way. If it is Q0 Q1, how to apply it? Simply take the first state Q0, apply 0. So the result is Q0 Q1. In the same way, take the next state, that is Q1, apply 0, that is nothing but Q0. Now union these two results. So finally the result will be Q0 Q1. So if the result is Q0 Q1. Now apply delta of Q0 comma 1. So Q0 comma 1 is equal to nothing but Q2 and same for Q1. So it is Q1. So union these two results. So that is Q1 comma Q2. So the result is Q1 comma Q2. So in the same way, take the next new state, that is Q2, apply 0 and here Q2 0 is 5. So here is also 5 and Q2 1 is Q0 Q1. Here it is also Q0 Q1. So pick up the next new state. So the next new state is Q1 and Q2. So Q1 Q2. So in the Q1 and Q2, apply 0 and 1. Delta of Q1 comma 0, that is equal to Q0 delta of Q2 comma 0, that is equal to 5. Union these two results, that is Q0. Now apply 1 for both of them. So delta of Q1 comma 1, that is equal to Q1 delta of Q2 comma 1, that is equal to Q0 Q1. So union both these results. So finally we'll get Q0 Q1. There are no new states and finally the process has been finished. So this is the transition table for the DFA. Now we can construct the DFA. Initial state is Q0. By applying 0, it is going to a state called Q0 Q1. By applying 1, it is going to a state called Q2. We can come to the next state Q0 Q1. By applying 0, it goes to the same state Q0 Q1 and applying 1, it is going to a state called Q1 Q2. Now come to the next state Q2. Q2 0 is 5 and Q2 1 is Q0 Q1. Next take the next state Q1 Q2. 0 is Q0 and 1 is q naught q. So for 5, if it is 0 or 1, it will be stay at the same state. If the state is 5, for input 0 and 1, it will be 5. So this is the final DFA. What are the final states in it means? So please take the final states in NFA. It is Q2. So please check in which states the Q2 are present. Here the Q2 is there. So it will be a final state. And here it is the Q2 is present. So this is also a final state. So finally this is the DFA. These are the states and those are the final states and complete DFA. Thank you.